Okay, we're heading into the halfway point of week 5 in Calc 1. We're in our last section that we're going to cover in Chapter 4, 4.7, on antiderivatives. And this actually is getting away from applications at this point. And we're just trying to get an understanding. The author is trying to lead you into the next big phase of calculus. We just spent our first phase in differentiation. The next big problem in calculus is called integration. And that's mostly what Calc 2 is about, but we do spend a few sections on it here in Calc 1 towards the end of Calc 1 and getting you into it. So in section 4.7, we're talking about this idea of antiderivatives. So what is an antiderivative? We usually label antiderivative with a capital F instead of a little f, because the capital F means it's the antiderivative of little f on some interval I. In other words, if I take the derivative of this capital F, I get back to f. Okay, so if I want all of the antiderivatives of some little f, then I can think of it as I need to find one, this capital F, an antiderivative, such that if I take the derivative of this capital F, it gets me back to f. But then I think about I need to add a bunch, any constant, because the derivative of any constant is 0. So there's an infinite amount of antiderivatives for any little function f. Just remember that. Okay, so in example 69, we want to find all the antiderivatives for each of the following functions. So a here, little f of x is 2x, and we're going to say little g of x is cosine of x, and b, and in c, little h of x is secant squared x plus 1 over 2 square root of x. Okay, so starting off with the first one, part A, it says little f of x is 2x. So I want to find the functions, or all of them, such that if I take their derivative, I get back to 2x. So you kind of have to think, well, what function, if I take its derivative, gives me 2x? So that's x squared, right? The derivative of x squared is 2x. Then the derivative of any constant is 0, right? So f prime of x is 2x, back to my little function f of x. So you think of it as almost a reverse power rule, right? Instead of taking the derivative of 2x, I want the antiderivative of 2x. So I add a integer to the power here. So the integer power is 1, add 1 is 2, and then divide by that. So I just get x squared. Maybe that's a little complicated for you to think about it this way. Just think about what function, if I take its derivative, gives me 2x, so it's x squared. All right, here's little g of x is cosine of x. So find all of the antiderivatives of little g of x. We're going to call them capital G of x. So what function, if I take its derivative, gives me cosine? Well, that's the sine of x. And then, of course, any constant, because the derivative of any constant is 0. How about little h of x is secant squared x plus 1 over 2 square root of x? Okay, so remember, 1 over 2 square root of x, when I think forward on that, like how do I get the antiderivative of these guys? Well, what function, if I take its derivative, gives me secant squared x? Hopefully you got that memorized at this point. That's tangent of x. And then the square root of x is the same thing as x to the 1/2 power, so the derivative of that would be 1/2 times x to the minus 1/2, which is 1 over 2 square root of x. So there is showing those derivatives. So in other words, that's my antiderivatives. Oop, I forgot to add the plus c here. Make sure you add the plus c everywhere, and if you're asked to find all of the antiderivatives.